Good afternoon. My name is Sami Zuhurudin. I'm a staff solution architect on the cloud platform team. I'm going to be talking to you today about cloud forensics, machine learning, serverless, DevOps, quantum computing, forensics, edge. No, that would be a great talk. That's like everything I could throw in there. No, the talk is Cloud Forensics 101, and I hope by the title that sort of that clued folks in. The 101 is sort of, we're starting with the fundamentals, we're starting with the basics, and then from there we're advancing. We wouldn't be in much shape talking about advanced subjects if we weren't covering the basics. So that's definitely kind of the level set. We're going to talk about techniques, practices, things you need to do for your environment, and hopefully leave you with a lot of practical things that you can do. This is not necessarily a talk about security. We do a lot to secure our environments, and perfect security is a goal. Perfect security should be the outcome or the goal of any security program, but we live in a world where infiltrations happen. That's just unfortunately the reality. We hear about them, and when we hear about them, they're not great. Sometimes we don't hear about them. They're taken care of internally. But when we do hear about them, they've been, in some cases, it's not uncommon to hear months or years that something has been allowed to sit there. Some bad actor has been allowed to act in our environment, and they're up to no good. They're up to stealing from us. Could be stealing sensitive customer data. It could be stealing our trade secrets. It could be stealing literally, half a penny at a time. That would make a great movie. But maybe it's not a half a penny, maybe it's half a coin. In this case, maybe it's half a Bitcoin. It's not an uncommon application where they're literally stealing your computing resources. But regardless, they're in our infrastructure. And if we turn it into an engineering problem for a second, our goal is to optimize the time from which they have possibly landed on our infrastructure, our environment, to the time we were able to detect and get rid of it. We want to optimize to minimize dwell time. We want to get, from the time they figure out how to create an exploit to the time that we're able to do something about that. We want that to be as little as possible, because the longer we allow that to fester, that's money potentially lost. So what are the objectives for today? What also amazes me is that, yes, infiltrators are making their way into our infrastructure despite security measures, but it's also, when these stories come out about how things happen, it's fascinating to watch the process and progression that professionals in that space are looking at, how to uncover the bad guys, the process they go through. And kind of one of the fundamental pieces is that it's not magic, it's forensic. They're looking at data, much like any other profession. They're looking at pieces of evidence that allow them to formulate a certain pattern of behavior and then uncover things. So today's activity really is largely focused around that activity. We're going to talk about a number of things we need to be doing in our environments to help that process along. We're going to go over the tools explicitly. This is kind of the highest level that we'll get to in the talk. The rest of the talk we'll talk about tools and configurations of tools and things that we can do. We'll also, at the end, we'll sort of wrap up with an example of what a whole forensics pipeline looks like. This is cloud, and so it wouldn't be complete without talking about things we can do in an automated fashion to really sort of make our whole forensics activities within our environments a little more seamless. All right. So, standard disclaimer. Going through your environments and looking for what a bad actor may be doing and try to uncover it and try to get it out of your environment, it's serious business. It shouldn't be taken lightly. There is tradecraft out there for those who are trained to look at incident response, to figure out, to find a bad guy within your infrastructure. And it's our job to help them. It's our job to really put together a very concise and very well-curated set of information that allows those individuals, if you're here, that's great, but allows those individuals to minimize the amount of time that something bad is inside of our environment. And to kind of analogize this to being medically informed and making sort of like, the good choices when it comes to sort of like, your diet or your exercise or things. You can get away with Googling a bunch of stuff to live really, a good life. But at some point or another, you have to decide, it's time to call in a doctor. It's time to sort of step it up. And that's the way I'd encourage you to look at the information we're going to present here. It is pretty handy, and it does sort of open your eyes to what's available. But try not to be over cavalier and know when to bring in the right resources. All right, so we're going to walk through these stages. These are sort of different stages of or categories of activities that we want to walk through in the process of helping prepare our environment for dealing with an incident. If an incident happens, we want to be as well prepared as we can. It's going to suck. It's not something we want to go through, but we can either be extremely poorly prepared, in which case we just don't know where to start. We're literally starting at square one. Or we can be in a much better position, and that's our objective here today, is to be in a much better position. And generally, we sort of move to the right of this orchestration of events, but our activities are going to fall in this bucket. And today, just to sort of in full transparency, today we're really going to be talking about collection. This is really how we boost our position and give an analyst or somebody that's investigating an incident the best ammunition to sort of move forward. I said we're going to talk about collection mainly, but it wouldn't be complete without talking about prevention. And by that I mean these are the kinds of activities that we go through in securing our infrastructure. And at a high level, you could think of it as the three-step sort of process is secure your perimeter, go through defense in depth, and then monitor how you're doing at any given point. But the reason this is important, this is sort of a symbiotic talk. I mean, there's so many talks regarding securing your infrastructure and how to properly lock things down. But insofar as when we talk about it in today's context, or in the context of forensics, the reason we do this is on its own value, it's incredibly needed with our environments. But if we don't do it, we're going to generate a bunch of noise, a bunch of garbage. And this is sort of the adage of garbage in, garbage out. If we've left everything wide open to the internet and we're just being bombarded with attacks, we don't want to float through a bunch of needless information to our downstream processes, our downstream analysis. We need to take care of making sure things like our software pedigree. If we are building software and we're sourcing components from different locations, are we keeping up with the security bulletins or the vulnerability bulletins with those libraries? If we're not, then that's something obviously an attacker is going to find and leverage and say, oh, they're using unpatched version X. We can we can use a well-known exploit. So these are activities that absolutely must be done. And if you don't do it, then it's not only just sort of weakening your environment, it's going to make it so that we're going to end up crying wolf a bunch of times, and making it really difficult for a professional to come in and properly analyze the environment. And by the way, I mean, not only is it time is money in terms of like how quickly we uncover where the bad actor has planted something in our environment. These resources generally that are doing the analysis, they cost money. You want them to come in and you want them to sort of not have to waste a lot of time on finding the right, finding the needle in the haystack. So, a great Englishman once said, who here likes audience participation? Let's organize into groups of 20. No, let's not organize into groups of 20. Let's call it out. What are some things that sort of clue out, cause one to think that they've been, that they have an incident going on, or somebody's found a way into their infrastructure? Go ahead. Spiked resource usage. Maybe go ahead. Anomalous network traffic, serverless. Yeah, go ahead. Blackmail, ransom notes. So there's a lot of things that go on. Point is, all those people are probably in the craft, and the point is everybody should have an incident response plan. If you don't, look around. It sounds like there's about 400 of us here that might be able to help out. But we should have an incident response plan to know what to do. It could be literally some authority or some law enforcement that's come and says, you have reason to believe that you're sending a lot of data to places you shouldn't be sending data. So whatever it is, think about yourself in that moment, and what are you going to do if somebody says, there is strong evidence here that you're going to be compromised. So this isn't that list of to-dos. I'm going to give you a couple not to-dos, okay? First one is do not simply say, oh my gosh, I'm panicked. I don't know what to do. Somebody's in my infrastructure. I know what to do. This is cloud. I'll hit delete. We don't want to do this for a couple of reasons. Number one is it just completely obliterates the the forensic trail that you want to follow. But in the chess match of, if you think about it that way, if you think about somebody trying to figure out how to take advantage of your infrastructure, you've made a very naive move. You've told your opponent that you really maybe don't have a game plan, you haven't figured things out, and if they were unaggressive at that point, they're going to get highly aggressive after they see that you're onto them. Maybe they're going to step up, exfiltrating all your data. Maybe they're going to step up their attack. Maybe they're going to lock you out of their infrastructure. So you will obviously terminate your infrastructure, but do it at the right time. Don't make a naive move that accelerates things needlessly. The key point is take a small breath, say, I have a plan, I know what to do. I'm not going to give away my hand and reveal to an attacker that I know they're in my infrastructure. Don't be a hero. Do not grab, don't be just, oh, we're infiltrated, I know what to do, I got this. I'll just log into the server using SSH so it's secure. Realize when there's a machine that's been compromised, that means somebody has figured out how to take advantage of it. And so in some form or another, if you log into a machine that's knowingly compromised, you are in some way handing over credentials to an attacker. So don't have the inclination to do that. Now these two things are very important because the rest of this talk is going to be largely centered around, so what do I do? How do I get around these things? I do want to know what's going on in these environments. But generally speaking, don't log in and sort of say, I know a thing or two about top and grep and PS, and I can look at logs. It's not our general plan. So the bulk of today is collecting things. Like we said, resources and the professionals that are going to come in to do this work for you. You could either say, I have no idea what's in my environment. Please take a look. Here are my credentials. Go ahead. And they're going to start from square one. Not only does that cost you time and money, it's just not an efficient use of time. We're trying to get folks out of our infrastructure. So we want to go through collection. We want, as part of our preparation process, things we're going to have done ahead of time, is to be collecting a lot of information so that when something happens, we're going to say, here is, yes, you're finding a needle in a haystack, but we've really curated the haystack down to make it a very small bundle of things. We think there's something in here. We think what you're going to find is in here. Please take a look. And it's generally these three buckets: logs, disks, and live information. Live information because more and more we're not in a situation where we're dealing with infected or compromised hosts that are sitting under our desks or sitting inside of our office. We're in cloud. So in cloud, you don't have that liberty, right? You have to think about how to do things over the wire, over the internet. And so more and more, we need tools and mechanisms to connect to things while they're online, while they're on the network. So generally, we're going to go through activities for the rest of this talk that are talking about how to collect logs, what to do about getting disks. Disks are obviously one of the most essential pieces of information in an analyst job, and then how to collect information real-time live over the network. Before we collect anything, though, we want to put things into a secured location. We don't want to collect all these, buckets of information and then have that bucket be a leaky bucket. We want to basically put them into a vault. And that vault, if you think about the Google project organization, you're going to have projects. Your projects are where your services are running, things that are talking to the internet, and this is where your quote-unquote compromised activity might be happening. But on the other side of that, your security apparatus within your organization, those who are responsible for collecting these artifacts, they should have their own highly isolated environment, a separate project, and that's designated for artifacts. It's for artifacts. It's a one-way flow of information, and we're going to set it up so that the only folks that have access to that is a highly sort of refined list of individuals. This isn't something that most people should know exists, but set this up first so that we have a destination for everything. So logs was the first thing in our agenda. Logs is a broad category. Anybody that's had to troubleshoot a problem knows that logs is your best asset. And within Cloud Platform, there's sort of two camps of logs. There's logs that we generate as part of Google that tell you everything about your environment. And these are admin activity logs, so who launched an instance, who modified a firewall rule, and data access. So if you're using any of our data products like BigQuery, and you're storing all your customer data in BigQuery, well, that becomes a tangible asset. That's a vector for somebody to try to come in and attack. So we can log activities regarding your data access. So we take care of that. These are platform-generated logs. The other side of the fence is logs that you generate, logs that your application generates. And so we're going to talk about basically each one of these individually and where you should destine these things. So the nice thing is that within Cloud Platform, there is a facility called Stackdriver Logging. This is how we surface all log information to you. But it's not simply for the platform-generated logs. It's a full-fledged logging service. And this is where you would instrument and say, hey, I'm going to be generating logs from my instances. I'm going to be generating logs from my application. Those are all going to basically end up in the same monolithic point. Now, if you have another logging instrument, that's fine. But the point is you should be sending all logs to some centralized place that allows you to pivot and look at it. Now, the platform-generated logs, like I said, those are just given to you automatically. They make their way into Stackdriver Logging. But you have to do a couple things in order to get user logs and application logs into that environment. So we'll talk about it as 3 phases: ingest, filtering, and export. So ingest is really simple. It's actually a very frictionless thing. When you're creating your VMs or when you're creating your environment, make sure to install a Stackdriver logging agent. It's a logging agent that's essentially a packaged fluentd agent. And that's really all you have to do. It's pre-configured to look at all the standard normal places within your operating system, your syslog and other activities. And as soon as it turns on, it's going to be able to use instance information, authenticate, and send it to the Stackdriver Logging API. You can do this from AWS as well. And install the logging agent on your EC2 instances, and it'll go effectively to one destination. In your application code, we have support for several different languages. Essentially, in your application code, instead of one approach would maybe just to be logging out to the system level logging. The other is your application code directly could instrument talking the Stackdriver API. And so you've got this sort of async process, which is just sending out log information. If you're running in serverless, so you're running in an environment where you can't necessarily rely on collecting the system level logs, you want to emit those logs directly from your application, then you would simply turn around with a lot of samples on how to include logging capabilities within your application code directly, and those don't necessarily need to go through the operating system. Once it's in Stackdriver Logging, I'm not making sort of any claims about sort of the volume of logs and the cost of logs and things like that. That's obviously something you should estimate and figure out how long data should sit there and where it should move and how much it will cost. But the nice thing is once it's in Stackdriver Logging, by and large, you get this sort of free-form search. You can do advanced filters, you can do custom filters, you can look at different things. Like if you wanted to know why a particular server is out of sync, you could simply look for what the NTP daemon was doing on a particular instance or all instances at a certain time. And this is going to be really instrumental later in the talk where we show you can do some fancy things with filtering that'll tell you, hey, there's something fishy going on. But most likely, this is sort of a pit stop. Stackdriver Logging is a pit stop on the way to something different. We want to save these logs. Like I said, the order of magnitude on these attacks is it's not a couple days or weeks. Sometimes we're finding out they're months or years. And so we want a destination to send these logs to long term. Stackdriver Logging gives you 3 outlets to send your information out to. BigQuery, which is kind of like the choice I would sort of default here. The logs are already structured, lends very nicely to export them to BigQuery, where they'll already be searchable and they'll already be able to query against. But then if you ever wanted them out of BigQuery in say a flat file format, you can always do an unload operation out of BigQuery. You could just send them flat out to cloud storage, or you could send them to PubSub. Those 2 key use cases are interesting because those of us who are operating another type of logging infrastructure, whether you're operating Splunk or something like that, or you have a SIEM. Your SOC is leveraging a SIEM, and you want to basically say, no, I have several different environments. I want everything to go into that SIEM. This is where you would pivot that information. You would say, okay, drop it into a bucket, and I'll set up a bucket trigger, and I'll know to basically pull that information in. In the case of Splunk and others, if you send it to PubSub, they're able to hook into that PubSub feed and bring things over. But the point is, the objective is to move it out. What does that look like from a technical perspective? We do something called setting up syncs. And the sync is just basically says, hey, Stackdriver, I know the data is inside of the Stackdriver platform. I want it out. And so you can, in a very terse amount of language, you can say, what is the log that I'm interested in? Essentially set up the filter, and where do I want it to go? What Stackdriver will do is it'll turn around and say, okay, I've gone ahead and created that for you. Here's a specific service account within your environment that's going to be used for this sync. And go ahead, and if you've asked for it in this case to go to BigQuery, notice these are not necessarily in the same project, because we have our forensics project, we have our security project where all this data is going. And so it's important to turn around and go to the data set or the bucket or wherever you're destining this information and say, oh, so I need to take that Stackdriver, that service account that Stackdriver told me I was going to use, and I need to grant it the appropriate permission to be able to write to that. So this is great. If you do this, you've got this kind of automated, every instance comes up, you make it part of the bootstrap process that every instance is going to be able to send this information off. But this just tells us syslog information. Syslog information is great in terms of standard system activities. It's not perfectly useful if you want to go much deeper. If you want to go at the forensic level, we need to look at, okay, what is this instance doing? What are the system calls that are being made? Who's asking for different things to happen? So we need to go and upgrade the amount of information we're getting from an instance. So within Linux, there's something called the Linux auditing system, which is something you can tap into. Every single activity, there's something like 300 odd syscalls that are being done within Linux, but you can look at every single activity. You can look at every time somebody touched a certain file, read a certain file. You can look at when somebody is asked to open a socket or listen on a socket. So this is when somebody is asked to run something with privileged information. This information is actually there and being emitted from the kernel all the time. There's a mechanism where the kernel sends it over to the user space for some tool to do what with it. It's not, the kernel doesn't really dictate that. It uses something called a netlake socket and says, I'm just going to dump this as a flood of information out on this. And so you can have things that listen for that and pull it off. auditd is one such tool. Another such tool would be OS query. The tool is really sort of your preference and your choice. But the point is you need something in user land to basically subscribe to that and take that off and then send it, in this case, to logging. So we need to instrument that a couple different ways, which I'll show in a second. But in this case, every time somebody's done something privileged, in this case somebody's done something using sudo and we're interested in that, it goes to Stackdriver Logging. Because we've pre-filled out the collection part of this with an agent, then essentially we just need to say, yep, this is one more thing I want to learn. Without this kind of information, it's very, very hard to really get a picture of what the instance was doing, what the VM was doing. You'll sort of maybe see some startup times, some application launch times. Without actually looking at kernel level activities or audit level activities, you may not necessarily know like who did what in what sense. Getting this on to an instance is pretty straightforward, pretty trivial. If you think about the previous slides, we showed, hey, you'd have a startup script, install a Stackdriver logging agent, great, pretty much with one command, you'd get all the Stackdriver logging. It's about the same here. Well, I guess there's a few more than one command. It's like a long command. So there's a couple different things here. One is we already sort of acknowledged that we're going to have the Stackdriver logging agent ready to go. But we're going to pull down auditd. And we need to do a couple things. One is we need to, in that top little block, in the audit rules, that's where we tell auditd, what am I interested in? So this is about the version that would fit on a slide. It's not necessarily meant to be prescriptive. You'd want to do some research on auditd and see what kind of calls are meaningful to be able to look at. In this case, where we're saying, tell me everything that has an effective UID of 0. Like basically tell me anything like on the previous slide that was being executed with sudo or as root. The other thing we need to do, the back half of that is great. We're generating all this information. It's going into audit log. Stackdriver by default doesn't know that this is a source of logging that we'd like to also include with the logs that come off of this box. So that end piece there that says is a configuration that says, hey, Stackdriver, go ahead and pay attention to this new log format that I've dropped out. And by the way, it's a little bit special. It uses some key value pairs. It has to be parsed a certain way in order to make it in. So that's roughly that's what that format key value is. But if you do this, great. You got everything that's happening from a syslog perspective. You got everything down to everything that the kernel is thinking about. So in terms of logging positions, we've got our platform logs, we've got our data access logs, we've got our application server, our OS logs, our application server logs. got everything that's happening on the instance. Now we know what's going down to the kernel. The last kind of piece of this is, from a logging perspective, is flow logs. Flow logs essentially tell you, I've just finished describing everything that's going on inside of an instance, everything that's going on from a platform perspective around an instance. This is sort of rounds out the piece. It'll tell me everything that's happening from a network perspective. Everything that's from a network traffic passing, I think somebody mentioned, looking for spurious network patterns. Everything that's being thrown back and forth across our instances. And it's not on by default. This is pretty chatty. It's a lot of data. It's a lot of traffic. But it's something that you would want to look at turning on. So you'd go in your subnet and you'd basically say turn flow logs on, and it's going to score every TCP and UDP flow. Some caveats, if it's a single packet type thing, it's based on sampling. So in some sampling senses, it may not pick up on very, very low packet, like single packet count type things. But if you've got something that's steadying a stream out, which is what a lot of attacks do, this would be a good way to pick up on it. And because it's in Stackdriver Logging, I can formulate this search pattern. Now here, obviously everybody recognizes this is a great DNS server to be using. This is Google's DNS server. So this isn't necessarily suspicious. What would be suspicious though is in your environment, if you're like, why do I have any outbound DNS traffic? I have centralized DNS within my environment. Instances kind of look inward. Why am I sending DNS traffic out to the internet? And there are some exploits that are actually pretty well known now that take advantage of exactly that, using DNS tunneling or DNS cat. They're able to sort of compromise a machine and say, make it look like a DNS query, but every time you make the query, just piggyback on this little tidbit of information, and over time that information gets accumulated on the other side. So this may be a very interesting query, not necessarily going to Google, but going out to somewhere that you didn't expect. All right, that is the entirety of logging. What the platform is doing, what your data is doing, what the instance is doing, very deep, and what's happening around it. So that kind of rounds out our picture of logging. Collecting that information, putting it in that logging basket, and having it be searchable because you've sent it to a searchable endpoint. You've sent it to something not only in Stackdriver Logging that you can query with some advanced queries, you've sent it to BigQuery. Now you'll be able to say, you know what, I think I need to zone in on everything that was running on a particular managed instance group, or anything with this particular tag, or anything with service A. You've got a point to basically come in and say, great, I'm going to carve out that set of logs and the traffic patterns and the kernel activities and send that somewhere. We'll talk about where to send it in a second. Disks. So this is usually that canonical forensic, hey, I'm going to do an investigation activity. They grab the disks and send it to somebody that may or may not look at them. So we grab the disks and look at it. So obviously in a cloud environment, we don't have the disk grab API yet, where you can tell a human being to grab it. But that's not what you want. Really what you want is the disk. And if you remember the don'ts, the things not to do, is do this in an obtrusive way. We don't want to do this in a way that reveals that we're doing something investigatory. Logs happen saliently. All those agents, as long as you make those part of your build-up, your bootstrap process, all that information is spewing, and nobody is really the wiser from an attacker perspective of how much information is being sent off. I mean, they probably perceivably look, but you're not instrumenting something after they're attacked. It's just part of the normal process. Disks are the same way. We don't want to terminate disks and say, oh no, but it's okay, I just said to save the disk. We want a much more salient way to instrument this. We want to use cloud APIs to do this a little bit better. So what this process would look like, or does look like, is to enumerate the instance or instances that you are interested in. Okay, service A is compromised, or microservice B is compromised. What are all the instances that are running that? Come up with a list of disks attached to those instances, and behind the scenes, use a platform to make a copy. And those copies exist in logical form from an object perspective within your cloud account. What we want is the tangible artifact that can be sent to a downstream tool. So what does that look like? It's actually just 3 commands. It is possible to take a running disk that's attached and make a snapshot from it. The reason we make a snapshot is because these disks are attached. If you wanted to make, it's a prerequisite for the next step, which is to create a disk image from a source. So you can create a disk image from a disk, a persistent disk, But if that persistent disk is attached, we can't do it. So first we take a snapshot, we create a point in time of a disk that's attached. We create an image, disk image from that snapshot, and then we can export that disk image. Now this may be something interesting just from your own operational perspective. How do I get information that's running? How do I get a disk image that's running on production and have a backup copy in case I needed to change environments or do something interesting? But this is incredibly effective because we can create an entire external archive in the form of a file that can be pulled into another tool for analysis. Again, an attacker that's running something on an instance you're running has no idea that this activity took place. Okay. That was it for disks. It's really, really straightforward and simple. It's one of the biggest things that you'll do in your analysis activity. But I'd like to move on to the last part of the puzzle, which is the last part of the things we collect, which is live information. Again, we need to talk to environments that are up. And so we're sort of done with the things that the platform and some agents and bootstrapping can do. We're going to move on to how do I look at something that is going on in the box? You've been informed there's a compromise. You know there's an instance that's compromised. I want to log in. I can't log in because that would give my credentials away. But clearly there's something running in memory on that box that's sending data out. So GR is an agent-based system. It actually installs on Windows, Mac OS, Linux. It's an open source project that started at Google a while ago. It actually stands for GR Rapid Response. To be cool, you say grr. I was talking with some of the folks that contribute and create to it, and I kept saying GRR, and they said that I wasn't cool enough to give the talk because I don't say grr. So say grr to be cool. Grr, know before you go. With great power comes? No, that's wrong. So it's a lot of extensive capability. It can let you do literally anything. And so it is that sharp end of the spear upon which you can do pretty much anything inside your environment. So it's probably a good idea to fortify the heck out of it. Effectively, it is the point at which you could be root on anything and look at anything. So there's an entire in the GR read the docs, there's an entire section on how to secure it. How do you front end it? How do you put the right certificates on? That would be an entire talk on its own. This is just my way to make sure that Google security people don't yell at me. So, but secure it before you move on. Okay. Once you've got GR up and running, there are two main activities. Agents or clients will report into it, but there's two sort of main things you would ask GR to do. A flow or a hunt. And so a flow is just an atomic unit of work. You're like, hey, that box right there, I'd like to look at a particular file. That box right there, I'd like to look at the memory that's running on that particular process. So GR can essentially start a flow and say, great, who do you want to target? What do you want to do on that machine? And then that machine would pull in and ask for if there's any work. A hunt would be sort of under this new banner of threat hunting. If you just sort of go from a premise of that you're always compromised, there's something always going on in your environment, then you may say, I know that there's the shape of this jar that's pretty bad, or I know there's this string that's pretty indicative of a compromise, and I want to be hunting my fleet for any time that shows up. So this is an example of a GR flow. I've asked for a process memory dump. So let's say, for an example, you have a machine. Somebody an attacker's on that machine and says, rudimentary, I'm just going to basically take this file, I'm going to dump the entire, creditcards.zip. No. Don't ever do that. I'm going to take that and basically make it look like some system level file because I've made it look like a swap file, and I'm going to just send it over a socket. I've only got 20 minutes on this box. And so you could send this over. And so now you've got this process which is online, which is active, which is egressing information. You're like, hey, that doesn't look right. So you start a flow and you say, I would like to dump that process. So GR will turn around, and then when that box makes contacts, and it'll say, hey, turn around and run this flow. And so you'll see in the GR console, it's like, okay, cool. I've got this piece of work here you've asked me to do. And it'll go and it'll collect, and then a few moments later, you'll see that, hey, GR will say, hey, I'm done. I'm done collecting this memory. I've stored it in these however many little artifact files, these files. You're ready to come check it out. Sort of like your dry cleaning is ready to pick up. And so you can pull those files down, and they're binary, they're files that represent the binary representation of what's in memory. So you could do something as simple as run strings on it, which would take that binary information and turn it back into text, and you could see that essentially what I had sent was sitting, whatever you had been sending, was sitting resident in memory for that process still. It hadn't been garbage collected yet, and you would be able to dump that out. And so it's pretty powerful to be able to say, look, I can actually look and reach inside of a box and look at the memory that's going on inside of it. It's not necessarily going to be this easy. This is trivialized, but the point I'm trying to make here is without GUR, you couldn't do this. Remember, you're hamstrung, your hands are tied behind your back because you can't log in. You don't want to log in. You know that's just a bad practice. But with GUR, at least you can effectively do everything you would need to do had you been logged in. GUR actually is designed to go onto agents like Windows machines, Mac OS machines that are out on the internet. The agents are available, and be contacted from, say, a fleet of instances or a fleet of workstations that you're managing. But in a cloud deployment here, if you're using in this sort of centralized context where you're having machines, instances spin up in different projects and contact in, we'd want to make it work in this sort of, again, segmented approach where not everybody has access to the GUR server. It is a pull model. So the nice thing is it's not GUR reaching out and making contacts and you having to deal with firewalls in every single instance. Agents on client-installed machines poll periodically for activity. And the nice thing is then if they're offline, they're offline. But when they come online, they can, they'll say, hey, do you have any work for me? And the other thing GUR does is it has customized install binaries. And so you'll put those binaries in a specific bucket, and you'll set up your internal firewall rules. But the way to do this sort of cross-project, because again, we want our security artifacts and infrastructure in a different project than our production ones, we'd want to set up VPC peering here. This isn't really that much of an of an interesting slide, but essentially it's a few steps. You can set up peering between two pieces of infrastructure, and the main thing there is to make sure you allow the relevant protocols into your GUR server. The GUR server itself is pretty easy to set up. It's got Debian packages. It comes with Docker. You can download a Docker image and run a Docker image. Part of the setup will interrogate you and ask you, what is the name by which clients are going to contact me? And you configure all that information in. What is the admin interface going to be on? You configure all that information in as part of the setup, and as it's doing the setup, it'll build custom install binaries. So it isn't something, and this is really salient because then these install binaries are just ready to go. So you'd put those into a bucket. That's basically where they sit on the management console. And what you want to do then is any piece of infrastructure in your environment, any compute that needs to grab those binaries, just make sure you give those access to the bucket. And that's it. It's a sort of a one pull down the archive from a bucket using gsutil and then install it. So now we've kind of talked about three things in our install script: Stackdriver Logging agent, auditd, and now the GUR agent. With this, we've got our logging information. We've talked about disk collection, and we've talked about getting information using live information. So let's move on to detection. This is kind of where it starts to get real. We're in a good position here. We're in a position that if somebody said, tell me everything that goes on in your environment, and you, instead of looking at them like a deer in headlights, which is easy to do up here with lights in your face, instead of that, you can go, I got this. I can pull a disk for you. I can tell you what's going on in memory. I can pull logs related to that incident. I can bundle this all together and hand it over. And so in detecting this is where you would employ any number of sort of services. Maybe you're hunting for malware. Maybe you're noticing that your instances are beaconing out to some, trying to make contact with the command and control server. Your IDS probe picks it up. Unexpected processes was called out earlier. Unauthorized syscalls. Why is something trying to listen on a port? So let's say you put that all together. This is an example of what a pipeline on cloud could look like, a forensics pipeline. If you remember in the beginning, I said we'd sort of pull all this together to make it look interesting. But imagine you have an instance that's beaconing. It's sending out to some bad known IP. So before the fact, you've sort of sourced a list of bad IPs. We'll talk about that in a second. And so you've got the machine beaconing, which you're able to find out because that's going in flow logs. And you've got a list of bad IPs that you've configured as a filter because you're like, hey, I can configure a filter to look for certain IPs. And if you notice that, you could tell some worker process that says, this doesn't look right. I want you to trigger off of that, and I want you to go and collect everything you know about that instance. And because flow logs are fairly chatty and that would keep repeating, you'd probably checkpoint these results somewhere and say, this is instance demo 1. It's been compromised. You don't want to kick off this flow every time. So you'd maybe collect that information in Firestore. And Firestore has a few different ways to use it. The way we're talking about here is closed. You don't want Firestore open to mobile and web. This is just basically a holding ground for. It's not a social app, so this is a holding ground to checkpoint your results. And so I would turn around and I would do that. I would say, collect me the memory, grab the disks, run this query to collect all the logs for that instance, and send those to the next stage. The next stage would be, I've got the memory, what do you want me to do? Kick off another process which turns around and analyzes that with volatility or recall or something. And I've got all these time-based artifacts. I've got disks, I've got logs. I want to put those together in a way I can look at them. You create what's called a super timeline, which is using some tools called Plasso and TimeSketch. And oh, by the way, as this activity was running, one feature of Stackdriver Logging is that you can use alerting. And alerting can then not only alert based on some metric, it can do notifications with PagerDuty and other things. And so your incident response team gets alert, comes in and says, hey, this bucket has a bunch of artifacts, or these VMs have a bunch of artifacts that have been loaded up in their analysis tools. They need your eyeballs on them right away. So this is not fictitious, actually. You can build this with everything we've already talked about and a lot of the things we've already shown, but I'll kind of just allude to the things we haven't quite talked about. So MISP is an organization, SANS is our organizations. These are well-known organizations that help collate and curate bad actor information, malware information. And so they do have the ability to sort of bring down a list. It could be earlier, like we talked about with DNS, where it's maybe a particular port that you know is troublesome. But in this case, you could say, well, I just want to download the top bad actor list. And because we're able to set up syncs programmatically, like we set up earlier a sync for archive, this is a sync that's different. You notice the destination is actually pub/sub. We've set up a topic here called, hey, beaconing. I think that if I see somebody talking these bad IPs, it's pretty good indication that they're beaconing out to make contact with someone. And so I could build this list and sort of refresh this on a basis. And if it triggers, boom, I'm going to send it to a pub/sub topic, and that will kick off the activities that you saw in that worker chain. So this payload comes in, and that worker says, what do you want me to do? Well, it turns out GR has an API. And so if this was the worker that's going to orchestrate the GR activity, it would say, cool, what's in the payload of this message that I just got in pub/sub? And the two things that are interesting there are the source IP and the destination IP. So the first thing I would do is I would contact the GR API, and I would say, give me the client that has this IP. And so GR would search his database and say, here's the client, or here's a list of clients. And then the next thing, which is more interesting, I would say, go do a netstat on that machine. Go do a netstat and tell me in that netstat who's talking to this bad IP. What process? Give me the PID of the process talking to this bad IP. And then it'll come back and say, well, here's the PID of who's talking to that IP based on the netstat. Great. Go dump me the memory for that PID. I want to know everything that's happening in the memory on that PID that's talking to that bad IP, because it shouldn't be. This is all done just basically talking and interacting with the GR API. And it started off with a trigger that was based on some information that we can easily source. The next thing in our pipeline after memory was building a timeline. A timeline essentially just says when you can take a bunch of data and extract the metadata that has to do with time on that timeline and lay it all out, then it's, you lay it all out so that it's chronologically able to be analyzed, and then layer on anything else that has that time element, because we're sort of hunting and finding a cataclysmic event and looking sort of around that to say, that's where that file was dropped and that's where that process was launched. That file was dropped on the disk based on this information, and that process was launched based on this user at this time. We want all that information. So we take all our logs, anything that's time sensitive, and our disks, we send them to log to timeline, and it creates a super timeline, a Plasso file. Plasso file would just be a file. It would be sort of hard to look at in sort of like a spreadsheet fashion. So we want a way to sort of bring that together and collaborate. So there's another tool called TimeSketch. TimeSketch is written by a Google engineer named Johan Berggren. I hope I'm saying that right. And it sort of has this, it's an Elasticsearch backed, but it has this ability to load in all this timeline information into sketches and say, hey, I want to bring in timelines. What this does is it's a focal point for all your analysts to sort of look at and say, there's interesting traffic right there. I want to annotate that. I want to come back to that in my workflow. I want to look at how that event connects to other events. And so you can do sort of all that collaborative exercise with TimeSketch, and you can have multiple of these going on if you have different events going on at different times. So how do I bring things into Plasso and TimeSketch? Well, I'd set up Plasso, I'd set up TimeSketch, I'd copy down the disk image after acquiring the disk image, I'd run log to timeline, I'd create a timeline. I'd basically do a bunch of stuff. And so what would be great is if I didn't have to do all this stuff. right? If it just somehow this could all be sequenced together where I could interact with the cloud APIs and interact with all these forensic analysis tools and sort of pull it together. And so I want to highlight a couple tools in closing here. Is Turbinia and TimeWolf. These are open source projects. They are used by certain teams here at Google as well, but they are available. And so Turbinia is, if you recall, like, hey, this activity, I want to create a I want to create a time sketch. I want to create a Plasso. I have this memory in these files. I want to run strings on it. So when you have forensic artifacts and you want to run an activity against those forensic artifacts, this is where you would orchestrate that with Turbinia. But you also notice in this whole pipeline, that whole long sequence of things, I was sequencing between different APIs in this process of building my forensic pipeline. And that's where a tool like DF TimeWolf comes in, where it can say, it's the plumbing or the glue that kind of pulls together disparate actions between these APIs in the goal of being able to kick off this, these more finer activities, say in Turbinia. So those are two tools you can look at that lean very heavily into cloud APIs. A question might be, hey, you've talked about all the things in VM world. How does this pertain to new computing environments like containers and serverless? And a lot of the things are applicable. In the serverless camp, actually, very little is applicable because you don't have control over the execution environment. You don't get the logs from that environment. But we do get it standard out. You know, that's generally what a serverless environment will pull out for you, is that it'll send to you whatever your environment was sending standard out. But in containers, there's some things we need to keep on top of. There's, if we're looking at the syscall activity, there's some utilities like sysdig, or you could use gvisor. There's a talk tomorrow here in this room, I think at 10:20, on gvisor, which is how do I look at what a container is doing? And gvisor kind of goes a step beyond. It not only looks at what a container can do in terms of syscalls, but it can sandbox those. So you can sort of have a whitelist of like, what should this container be able to do? But because it's sandboxing and intercepting those syscalls, it actually can log off of those. So if that sounds interesting, attend that talk tomorrow. gvisor is open sourced by Google recently, and it's super interesting. And there's a couple different ways to run on Container Engine. One is using Container Optimize OS, and then the other is Ubuntu. And so if you want to sort of install any of these things or work with the base operating system, that generally means you're going to pick Ubuntu. And then the VMs are basically everything we talked about, but it's probably helpful to sort of look at this compare and contrast aspect. Okay. So, bottom line is, kind of the leave behind, is that don't go into panic mode when something happens. When you've been alerted to something going on, have a plan and say, the data, you know, the analysis is going to show that this information can be found out by looking at certain data. And that data is going to be your logs, your disks, and your live information, and have that ready to curate and pull together. So when something happens, follow the plan, gather data, use the tools mentioned to collaborate. It'll take many folks working together to sort of pull all the information together and find that needle in a haystack. And then again, be sure you bring in folks that know what they're doing or have been trained to know what to look for. So if the patterns in this talk seemed interesting to you and there's some of the things that you look to employ, we'll be probably publishing these in the form of a solution. I work on solutions that I publish out to the community, and I'll probably try to publish these out. But if you want to get in touch before then and sort of talk about these patterns, please reach out at next18-forensics@google.com. So thank you, and hope you enjoy the rest of the conference.